Number 24. Let g of x be the inverse function of f of x equals 5x times the square root of x. Find the smallest positive integer value of x such that g of x is greater than 2. So, the way you can do this, well, we just have to find the inverse function first. So, I'm going to rewrite this as y equals 5x times the square root of x, which is the same thing as 5 times x to the 3/2 power, right? This is like x to the first times x to the 1/2. So together you just add the exponents. So then if I divide both sides by 5, you get y divided by 5 equals x to the 3/2. And then raise each side to the 2/3 power, and you get something like this. And so now that I've solved for x, we know that this is the equation g of x equals x over 5 to the 2/3 power. So we have to find the equation, or we have to find the positive value of x such that g of x is greater than 2. So we just take this equation, set it greater than 2, and just solve. So first thing we can do, we take each side to the 3/2 power. So x over 5 is greater than 2 to the 3/2. And then multiply both sides by 5. So x is greater than 5 times 2 to the 3/2. So if I do this, 2 to the 3/2, that's 2.82, and then times 5, so we get 14.14, and so then we have to find the integer right above that, so the answer would be 15. If you notice here, though, once we solved for the inverse function, whenever we went backwards, so see right here, we had y equals 5x square root of x. We go backwards and solved for g of x, but then whenever we solved our equation in the end, we went and just did it backwards. Notice this is sort of like, this right here is just 5 times 2 times the square root of 2, just like our equation up here. And so in reality, what we could have done is just plugged in x equals 2. And this is not a coincidence, this is actually just part of inverse functions. So yeah, so you just plug in 2, and that's a faster way of doing it instead of having to solve and then going back, you could just plug in x equals 2. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.